Hi, this is Vishal Singhal from Shellstat. Today we have Mr. Takuma Kimura, also assistant professor in HR in Hosei University, Japan. He's artificial intelligence intern with Shellstat AI Lab Bangalore, and he will be taking us through customer churn prediction, talking about classification using XGBoost. This session is being recorded, so you can keep your questions sending, and we'll try to answer them towards the end of the webinar unless they're slide critical, when we'll try to talk about it on the slide. And yeah, so you will be able to see the recording in 2-3 days time over our self-study YouTube channel. I shared a link of it while the webinar is on. So Takuma, you are ready?
Yes, I'm ready.
So I'm making you the presenter. Go ahead and share your screen now. Great, go ahead.
Okay, I'm ready. Good evening. I'm Takuma Kimura from Tokyo, an intern on Salesstrat. Thank you for the opportunity to present my intern project today. Let me introduce myself briefly. I have engaged in research in business administration for more than 10 years and have conducted research using statistical analysis and qualitative studies. I took this self-start course to learn machine learning techniques to apply them to business practice, such as human resource management and marketing. So let me start my presentation. What is customer churn? This presentation is about the application of machine learning to customer churn prediction. It is one of the most popular topics in marketing analytics, both in research and practice. Customer churn is conceptualized in several ways. Some researchers define it as customers switching from one service provider to other service providers. Other researchers refer to it as the likeliness of customer to stop using service. Because customer churn includes both of these aspects, this research defines customer churn as the behavior of customer that stops using the service irrespective of whether the customer switches to the other service provider or just ends the use of the service. Let's go to the next slide. The practical importance of customer churn prediction derives from the fact that acquiring new customers require much more cost than retaining existing customers. According to the prior studies, acquiring a new customer is 5 to 6 times more costly than keeping a new customer. In addition, customer churn can injure the company's reputation, and churners can spread bad word of mouth. Moreover, because of the Web 2.0 technology, such bad word of mouth, a bad reputation will spread rapidly through blogs, online reviews, and social networking service, and so on. Therefore, recently, more and more managers try to build effective customer churn models, customer churn prediction models, to identify who will churn and who will not. Based on the business model that the product or service relies on, customer churn can be classified into two types, contractual churn and non-contractual churn. These two types. Contractual churn occurs in subscription type business. In the case of contract churn, customers cancel their subscription of the product or service. On the other hand, non-contractual churn happens in pay-as-you-go business models. In contractual churn, customer churn is easy to be identified by subscription cancellation. However, in non-contractual churn, churners are hard to be defined and identified. because customers can stop purchase without explicit cancellation or termination. Let's go on to the next slide. Therefore, customer churn prediction attract attention more in subscription type businesses. Telecommunication industry is one of them. Although customer churn prediction has already acquired much attention in this industry, it is getting more and more important in this industry. The technological advancement and the market growth of the information and communication technology have caused high competition in telecommunication industry. And various types of services provided by telecommunication service firms enable customers to search for better service providers easily, and thus promote customers to move from one provider to another. Therefore, this project focuses on predicting contractual customer churn in telecommunication industry, that is subscription type business. Let me talk about the application of machine learning to customer churn prediction. Thanks to the advancement in technology for storing and analyzing a large volume of the customer data, data mining has become an important tool for marketing analytics. In accordance with this emerging trend, data mining has been applied to customer churn prediction. Customer churn prediction can be defined as a binary classification problem, in which customers are classified into two classes, churners and non-churners. Since classification is a type of problem that can be addressed by supervised machine learning, marketing analysts mostly apply machine learning techniques to customer churn prediction. And many research showed the effectiveness of such application of supervised machine learning. Let me summarize our business problem here. Customer churn prediction is important as one of the practice for customer relationship management. By identifying who will churn and who will not, we can develop effective and efficient measure to retain customers. And thus, here, our objective of data modeling is to develop a model that can predict who will stop purchase and who will continue subscription. To develop such a model, we can define this problem as a classification problem of supervised machine learning. And we can apply supervised machine learning techniques to a data set of consumer behavior. Let me review some research in this field. According to the review by Liang et al., this study, the model used in telecommunication customer churn prediction research can be divided into two stages. First stage means earlier studies, and the second stage is recent studies. In the first stage, the commonly used methods are traditional classification techniques, such as logistic regression, support vector machine, and naive-Bayes decision tree, and artificial neural network. Some of these studies showed the difference in prediction power in traditional machine learning methods. Specifically, previous studies showed relative superiority of support vector machine in customer churn prediction. In the second stage, it is the current stage. Research have begun to use ensemble models like bagging, boosting, random forest, and XGBoost. Ensemble methods meta algorithms that combine multiple machine learning models to improve predictive performance. In general, past studies show that ensemble methods achieved higher performance compared to the traditional methods in customer churn prediction. Among ensemble methods, random forest is the most popular and it showed higher performance than traditional methods. I refer to some studies here. They show that random forest is a better predictor for other methods. Let me talk about XGBoost here. XGBoost stands for Extreme Gradient Boosting, which is an advanced method of gradient boosting. It is a supervised learning method that combines trees and averages the result to generate a more generalizable boosting classifier. In 2015, many of winners used XGBoost in the Kaggle competition. Then XGBoost was moved into the limelight. Because of its performance superiority and efficiency in use, XGBoost has become one of the de facto method of the first choice in supervised machine learning problems, and has been widely applied in various fields such as cancer diagnosis, medical record analysis, credit risk assessment, and so on. XGBoost is an ensemble method that uses boosting technique. Boosting combines many weak learners into one very accurate prediction algorithm. Weak learners mean learning algorithm that only predicts slightly better than random. Boosting is a sequential algorithm. In that, in boosting, a learner is trained by using the results of the previous learner's prediction. It means sequential, like this. This iterative process improves the model performance. Let's see the process of gradient boosting. The left column represents the residuals of tree predictions, and the right column shows the ensemble's prediction. In the first row, this row, the ensemble has only one tree, and thus its predictions are exactly the same as that of the first tree. In the second row, a new tree is trained on the residual errors of the first tree. Right figure in the second row, this one, shows the ensemble's predictions, which are equal to the sum of the predictions of the first two trees. Then in the third row, another tree is trained on the residual errors of the second tree. As you can see, the ensemble predictions gradually get better as trees added to the ensemble, like this, get better. There are some strengths in XGBoost that make it slightly better than unusual gradient boosting. One of the most important points is that XGBoost implements parallel pre-processing at the node level, which makes it faster than usual gradient boosting. Besides, XGBoost includes a variety of regularization techniques and that reduce overfitting and improve overall performance. We can select the regularization technique by setting the hyperparameters of the XG algorithm. In general, one of the notable characteristics of customer churn data is that it is imbalanced data. Imbalanced data is a dataset that has one or more classes with very low proportions in the training data as compared to the other classes. And imbalanced classification problems is a classification modeling that is built on an imbalanced data. Imbalanced data and imbalanced classification problems prevail widely in real-world domains, and customer churn prediction is one of them. That is, in many cases of customer prediction, churners are quite or relatively rare, small compared to non-churners. And the goals of the classification is to detect potential churners. There is a challenge in imbalanced classification problem. In an imbalanced classification problem, the minority classes occur infrequently, and thus the classification model is likely to put less importance on the minority classes. Therefore, the test samples in the minority class will be misclassified more often than those in the majority classes. So high imbalance can be a serious problem when the purpose of the prediction is to detect minority. For example, churners in customer churn prediction. I mean, in customer churn prediction, it is important for us to detect churners rather than non-churners. So in customer churn prediction, we need to take necessary measures to handle imbalanced data effectively to improve prediction performance. So let me talk about the approaches to handling imbalanced data. As approaches to deal with class imbalance problems, 4 approaches has been proposed. Data level approaches, algorithm level approaches, cost-sensitive learning approaches, classifier ensemble techniques. Data level approaches apply resampling to have data distribution rebalanced in order to eliminate the effect of the imbalanced class distribution in the learning process. Algorithm level approaches create or modify the algorithms that exist to take into account the significance of positive cases. Cost-sensitive learning approaches combine data level and algorithm approaches to incorporate different misclassification costs for each class in the learning process. And classifier ensemble techniques construct ensemble classifiers by combining multiple classifiers and their decision to make the final decision. Among these 4 approaches, data level approaches require less computational time for data preparation because it needs data pre-processing only once, and therefore have been frequently applied in customer churn prediction. So this research project adopts data level approaches. The popular methods of data level approaches are undersampling and oversampling. This is the figure about the undersampling. Undersampling lowers the imbalance ratio of the dataset by reducing the number of samples of majority class. Here, the green. So this is random undersampling. So from this majority class, randomly selected samples only used the application. However, since undersampling uses only a subset of the whole dataset, it could lose important information of the majority class. For example, this data information lost, and therefore lower the predictive performance. So when we use small or medium-sized data, undersampling is not appropriate. So oversampling is a better way to deal with imbalanced classification problems. So let me talk about oversampling. Oversampling lowers the imbalance ratio of the dataset by duplicating the samples of minority class like this. This is a minority class data and duplicate 5 times. So the imbalance is vanished. Although, I'm sorry.
There is a question, Takuma.
Yes, okay.
Can you explain undersampling with a real-world example?
Undersampling? Not oversampling, undersampling?
Yeah, undersampling with a real world example.
Real world example. This is not a topic specific. It is very much data, very many data of the majority class, and many similar data, similar pattern of data included in majority class.
He's asking about some real world example relating to real life. If you can give an example on that.
The example covers a lot of field. Customer churn, we can use undersampling, even customer churn prediction. But we can apply customer undersampling to customer churn prediction only in some cases. For example, the majority class is very large. So in this figure, this is minority class is 20%, about 20%, but the 20%, when in case we can undersampling in customer churn prediction, the majority class is very large and many observations, and one more condition: the majority class similar cases. Not diverse data. So for example, only customers in Tokyo and customers in Tokyo, young people, and similar pattern. If we have various types of customers, for example, Japanese youngsters, Indian old people, and American middle-aged person. So in such case, selecting a subset of the data lose much information from the majority class.
One example could be credit card fraud detection or poll exits or things like that.
One example is one concrete example is a customer churn prediction in online social game. So because in such game, a game user, the player mostly consists of youngsters. So the sample consists of similar individuals. So in such case, we can use undersampling.
Sure. Thank you. Go ahead.
Okay, thank you. Yes. Yes, let me explain about oversampling. Oversampling lowers the imbalance ratio by duplication like this. So we use same data for 5 times in this example. Oversampling decreases the efficiency of learning because it enlarges the learning dataset. Learning dataset becomes bigger. But the oversampling is a better choice because it retains all existing training samples. Undersampling, we can lose information, not selected samples. But in oversampling, we can use this data, all of the minority data. And there are 2 popular methods of oversampling: random oversampling and synthetic minority oversampling technique. Random oversampling randomly choose the data points in the minority class and duplicates them to balance the class distribution. This can create balanced data in a simple way. But random oversampling are likely to cause a problem of overfitting because the same data points will be used repeatedly in the learning process. Recent studies use SMOTE, synthetic minority oversampling technique. SMOTE is another way of oversampling, which can overcome the weakness of random oversampling. In SMOTE, class balance is created by adding synthetic samples to the minority class instead of simply duplicating the data points. SMOTE uses samples of the minority class to control the generation and distribution of artificial samples to balance dataset. SMOTE assumes that the sample constructed between the nearby samples in the minority class. In order to avoid the overfitting while expanding in minority class region, SMOTE generates new instances by operating within the existing feature space. For each minority class instance, SMOTE interpolates values using k nearest neighbors and creates attribute values for new data instances. More specific explanation using formula and figures. The basic principle of SMOTE algorithm is as follows. First, for each sample in the minority class, xi, the k nearest neighbors belonging to the same class are searched. Secondly, randomly select one sample from the k nearest neighbors. Then construct one new artificial minority class sample, x new, between the two samples using this equation. So let's understand the SMOTE algorithm intuitively by using this figure. It is cited by Ma et al. Studies. The figure depicts the algorithm of SMOTE processing. The white circles, these ones, majority class samples, and the cross marks, these minority class samples. The SMOTE algorithm first randomly chooses samples of the minority class. So in this case, this one, this cross mark with red circle, which are depicted as here. Then from this sample, it identifies 5 samples of minority class using k nearest neighbor. This one, this one, this one, this one, and this one. Then from the selected 5 samples, it identifies randomly choose the one sample from this 5. So first randomly select this, and k nearest, using k nearest neighbor, 5 samples are selected, and from 5 samples randomly selected one, this one, and generates a synthetic minority instance by interpolation. Interpolation means between the this first one and the randomly selected one, and between these a new artificial sample is interpolated. This is the structure of a SMOTE process. So like this, using these processes, minority classes increased. Oversampling can be effective, but it can result in overfitting. When some majority class instances are invading a minority class space, or like this, oversampled minority class are invading the majority class space. So resulting classifier can fall into overfitting. Therefore, combined use of oversampling and undersampling here, we call it hybrid methods, can be achieve better performance. One of the popular methods of hybrid approach is SMOTE-ENN, which is shown to achieve the best predict performance for datasets, which are highly imbalanced and very few instances minority classes. Yes, this one, SMOTE-ENN. This is a combination of SMOTE and edited nearest neighbors, that is ENN and undersampling. So this is a combination of oversampling and undersampling. ENN removes the instances from both classes, minority class and majority class. The instances to be removed are selected on the basis of the number of nearest neighbors misclassified. For example, if a data point belongs to the minority class and its 3 nearest neighbors misclassify the data point, the nearest neighbors that belong to the majority classes are removed. So let's go into the process of analysis. So first, let me talk about the dataset. The dataset used in this research is an open source customer churn dataset in telecommunication industry, which we can retrieve from Kaggle website. This URL. The raw data contains 7,043 observations and 21 variables. The variable named churn is binary one, yes or no. That is used as the target variable in the following analysis. It contains 1,869 churners and 5,174 non-churners. The percentage of churners is 26.5%, and thus the dataset can be regarded as an imbalanced data. This is the list of dataset columns. The features included in this data are listed here. They are all about customers' characteristics, like the gender and ID and use of internet service provider. Data analysis followed the ordinary machine learning process, acquiring data, data preprocessing, train model, test model, and model evaluation. Here, as algorithm, I apply XGBoost to customer churn prediction and compare XGBoost performance with those of other classification methods. We choose other classification methods based on the performance in the previous studies. So in the previous studies, a random forest and the support vector machine showed a higher performance. So I used the support vector machine and the random forest for comparison. And to examine the effect of oversampling and hybrid rebalancing method, the classifiers will be applied to the 3 types of data. That is, original data, original imbalanced dataset, and dataset oversampled by using SMOTE, and dataset rebalanced by using SMOTE-ENN. As for XGBoost, instead of applying default value, I can set specific values to the sum of the hyperparameters. Specifically, the learning rate equals is set to 0.01 here. And the number of estimators, that is number of trees, set to 100. And the maximum depth of the tree is 3. And a subsample ratio is 0.8. And gamma, it is a minimum loss reduction required to make a further partition of a leaf node. It's set to 1. So before going on to the model evaluation, let me talk about the performance metrics used here. In classification problem, accuracy is the most widely used and intuitively understandable performance metrics. Accuracy represents a ratio of correctly predicted observation to the total observation. It is calculated by dividing the sum of the number of true positives and true negatives by number of all observations. Here, true positive means customers who are predicted as churners and actually churners. True negative here, customers who are predicted as non-churners, but actually actually non-churners. Many studies on customer churn prediction use accuracy as a performance measure. However, as you know, accuracy does not guarantee the excellence of the model when we use imbalanced data. Let's see the fictitious example in the slide. This is a confusion matrix using fictitious data. In this example, if only 5% of observations are churners. If only the 5% of the observations are churners, prediction model can easily achieve 95% accuracy by just labeling all observations as non-churners, like this. In such cases, the model is useless because no churners will be predicted as churners. So true positive is 0. So this model is useless. Besides, in general, in customer churn prediction, cost of false negatives is higher than that of false positives. Here, false negatives means customers who are predicted as non-churners, but actually churners. Because obtaining a new customer costs much more greater than retaining existing customers. So predicting churners correctly is more important than predicting non-churners, as I said before. Instead of accuracy, sensitivity is very important in this kind of problem. I mean, in classification problems like customer churn prediction, sensitivity is very important and useful. Sensitivity is a ratio of correctly predicted positives, positive observation to the total number of actually positive observation. It can be calculated by dividing the number of true positives by the sum of true positives and false negatives. In the context of customer churn prediction, sensitivity means the degree to which the model correctly predicts the actual churners as churners. Sensitivity is important in terms of identifying potential churners, but too much false positive is also problematic because too much false positives can result in excessive expenditure for customer retention programs. We also need to pay attention to another metric called false positive rate, which means the ratio of false positives to the number of actual negative observation. That is the sum of the number of false positive and true negatives. And there is a trade-off between sensitivity and the FPR, false positive rate. It should be noted that the true positive rate is equal to sensitivity. There is a trade-off between sensitivity and FPR. The higher the sensitivity, the higher FPR is. To handle this trade-off, AUC ROC score. ROC-AUC score can be used to evaluate the model performance. Let me talk about AUC score. ROC stands for Receiver Operating Characteristic Curve, and AUC stands for Area Under the Curve. ROC is a graphical plot that plots the sensitivity true positive rate and against the false positive rate at the various level of classification threshold, like this. which is a boundary probability on which each observation will be predicted as positive or negative. And AUC score represents the entire two-dimensional area underneath the ROC curve, this area. It can be high when FPR is low, and TPR is high, like this curve. Therefore, the higher the AUC score, the better the model is. In general, 0.88 is a good value for AUC score. So let's go to the analysis. We can oversample the training data by using this Python code snippet. This is a code of SMOTE. It should be noted that we must not oversample the test data, only training data like this. We have to keep the test data as it is. Similarly, we can use SMOTE-ENN in Python, only for training data. But when we use SMOTE-ENN, we need to import SMOTE-ENN and edit the nearest neighbors. In order to use XGBoost for classification, we need to import XGB classifier from XGBoost. Here, I initialize XGBoost classifier with setting learning rate, number of estimators, maximum of depth, subsample, and gamma.
Excuse me.
Yes.
So question is, higher the sensitivity, higher the FPR. Can you please explain this?
I'm sorry, again, please.
Higher the sensitivity, higher
Yes.
the FPR. Can you please explain this?
Right. So yes. Please refer to the formula of the. I'm sorry. Okay. Yes. So sensitivity means this can calculate this formula. So it is a formula true positives divided by true positives plus false negatives. So this is area this one divided by this one, and sorry for false positive rated false positive divided by positive and true negatives. So false positives this one. So
So you had said higher the FPR, sorry, higher the sensitivity, higher the FPR. So gentleman is asking explanation of that. What do you mean by that?
okay. So
No issue. So if you are not able to get it right now, you can let me know later on. I can pass it on to him.
It's a difficult question.
So don't worry, Takuma. I'll pass on the answer to him later on. You can send it to me later on.
I'm sorry.
Go ahead.
Sorry. So
Go ahead. Go ahead. Don't worry.
Okay.
Continue.
So, yes. Sorry. I can explain later more in detail like the question.
Sure.
Let me consider some time for creating clear explanation. So let's first go on to the results accuracy. So this one is a result of accuracy. First, let's see the accuracy of the original data set. So in this original data set, the accuracy is the highest in support vector machine, but it is the highest in random forest when using SMOTE or SMOTE-ENN. As you can see in the table, in all classifiers, accuracy is the highest in the original dataset and lowest in the SMOTE-ENN. The reason of the decrease in accuracy when we use SMOTE and SMOTE-ENN is the increase in false positive rate. So let me check the false positive rate here. So as you can see, the false positive rate, I'm sorry, for all classifiers, the false positive rates increase significantly when we use SMOTE and SMOTE-ENN. For example, by applying SMOTE-ENN to the dataset, the false positive rates further increase for the classifiers. So in particular, the false positive rate is greatly increased for XGBoost classifiers. So let me go on to the sensitivity. As shown in the table, for all the classifiers, the values of sensitivity are the lowest when we use the original dataset here. The sensitivity is lower than 50% in support vector machine and the random forest. So in XGBoost further lower. So these models are not useful in customer churn prediction. As then when we use SMOTE and SMOTE-ENN, the sensitivity improved significantly. Comparing between these, all classifiers, SMOTE-ENN show the highest and in among the three, and XGBoost showed the highest among the three methods, about 0.927, and followed by support vector machine and random forest. So when we use SMOTE-ENN in this data, XGBoost showed the highest performance in terms of sensitivity. Now let me go to the AUC score. So the result of the score summarized in this table, and rebalancing methods only. As you can see, the rebalancing methods, I mean the SMOTE and SMOTE-ENN, only slightly improve the model performance in terms of AUC score. These results are not surprising because this score is not affected by class imbalance. But when we use SMOTE and SMOTE-ENN, all the classifiers achieve the high levels of AUC score, I mean over 0.8 here. among the classifiers, XGBoost achieved the highest AUC score. However, the differences from support vector machines and random forests not so large. I mean, the older classifier show a good performance in this data. Before going to the the next slide, please let me go back to the explanation here. So I forgot the explanation, this one. I mean, as you see, the AUC score is almost 0.88 in all classifiers. So I said about the trade-off between false positive rate and true positive rate, and this happens because of the change of the threshold. So I mean, this one. So because when we change the thresholds, the results go on to the true positives to false negatives, because we increase or decrease. We can increase or decrease the thresholds. So it depends. I mean, if we increase the thresholds and decrease the thresholds, that results move to positive to true positives to false negatives, and false positives to true negatives. So this move of the data true positives to false negatives and false positives to true negatives change the value of the sensitivity and false negative rates. So if we change the thresholds to increase the true positive rate, the false positive rate can be reduced. Can be higher. So a true positive rate, high true positive rate is a good things, but the false positive rate, high false positive rate is not a good things. A more intuitive explanation is the change in the thresholds. I mean, the 50% of thresholds is relatively strict, and 20% thresholds is relatively generous. So if we decrease the thresholds to 50% to 20%, we can easily identify a positive case. So the true positive rate can increase, but such change, I mean, thresholds 50% to 20%, we can include false positives. I mean, the thresholds is too generous. So in such case, in this case, customer churn prediction, low thresholds is a risk avoiding prediction. So only 20% of churn can be identified by churn, but such thresholds change can increase the false positive rates. So true positive, when we want to increase true positive rate, so by decrease the threshold level, it results in increase in false positive rate. Sorry for back and go. So let me compare the results with my results with previous studies. These studies published in previous journals and a conference paper. So I choose these three studies because these studies use the data set same as this project. So Unfortunately, these research papers did not explain how they deal with the class imbalance. But anyway, comparing the result of the sensitivity, this project achieved higher sensitivity than the previous studies, meaning that the model trained in this project can predict churners better. However, because of the high levels of false positive rate, the XGBoost classifier in the study showed the lowest accuracy when it used the SMOTE-ENN. So this is the weakness of this study. So as we have seen, SMOTE-ENN contributes to the improved sensitivity. However, accuracy lowered when we use SMOTE and SMOTE-ENN because of the increase in false positive rate. So when the cost of churn is significantly large, application of SMOTE-ENN is effective because sensitivity is critical in such a case. However, in case of retention management, retention management needs. I'm sorry. However, when retention management needs much cost, low accuracy will be detrimental because it requires additional expenditure for retention. And the second point, XGBoost shows higher performance, specifically in sensitivity. But this data, support vector machine and the random forest, also showed high performance. That is, regarding this data, the performance of XGBoost is not overwhelming. I think the reason is that the dataset is not so large. I mean, the dataset does not contain so many observations and features. So application of XGBoost is will work better when we use larger dataset, and the SMOTE-ENN will work better because when we use a larger dataset and more imbalanced data. I mean, only 5% or 10% of the minority class. That's all for my presentation. Thank you very much.
Takuma.
Yeah, thank you very much.
In terms of time taken, how do they stack up? And also on computational resources required, if you would know.
Yeah, I'm sorry.
In terms of time taken, how do they stack up? And also in computational resources required, if you may know. Would you be able to respond to that in terms of XGBoost classification? How do they stack up in terms of time taken to do that classification?
Maybe XGBoost work better with the many features. This dataset contains only 21 features, but maybe XGBoost work better when we use a dataset with 40 or more features, I think.
And how do we handle variance and bias in dataset?
Yes, but my question is why the accuracy become very low when we apply SMOTE and SMOTE-ENN to XGBoost.
So would you be able to respond to that?
Maybe I misunderstood your question.
How do we handle variance and bias in dataset?
Variance and bias. You mean the training accuracy and the test accuracy?
Yeah, training and test, as well as how will you handle bias in the data set if there is any?
Yes, yes. I use this SVM and random forest, and default first I use apply default SVM random forest. I mean, not use cross validation, and then I use cross validation to and compare the result of the test data performance and training data performance. So, but the cross validation also add value to the results. I mean, just using default set of SVM and random forest, the training accuracy and test accuracy almost same. And in the in this SV classifier run rate, in this case, we can use XV classifier without setting these hyperparameters. But when I use XV classifier without setting these parameters, the variance is very large. So the test set performance accuracy very low. So I search the appropriate value using the cross validation, and I find this hyperparameter maybe better and maybe best for the reducing the variance.
Okay, okay. Thank you. Thanks, Takuma.
Thank you very much.
The audience, thank you for joining the webinar, and you'll be able to see the recording in 2-3 days time. I've shared the link already, and look forward to see you in future webinars, as well as we have one more presentation, I think, by Takuma in coming days.
Okay, thank you very much.
So have a good night to all, and Takuma, keep safe in Japan. I believe we are entering the fast proliferation stage now, stage 3 or 4. So be safe, and good night to all.
Yeah, thank you very much.